So 214 is called log function, context, and data modeling. So we've done the context and data modeling with all the different kinds of functions. This is your real world experience at word problems. Okay, these are the really fun stuff. The good news is that your calculator does a lot of this work for you. It does bring back in a little bit of the exponential stuff, but this is heavy calculator. All right, so first of all, topic is log function, context, and modeling. This is our real world application section. We've done this with exponential, we've done it with linear, we've done it with quadratic, now we're doing it with log. So this is a lot of word problems, I'll warn you, okay? There's a lot of word problems in real world application stuff. You do, but I mean, there's only 6 slides, so if we can get through them. Yeah, because you're too far out. It's on your to-do list yet. Yeah. All right. So the first thing, we already talked about the top part of it. You guys, shh. You gotta stop. The top part we have already talked about, and that is when you are given data, one of the options of what does this data represent is now going to include log. And to identify that the function is log, we look, the input values are being multiplied, right? So you can say the input or the independent values are being increased proportionally or decreased proportionally or multiplicatively. Like you can use those two interchangeably. And then the output values increase at a constant rate or additively. Those two also can be used interchangeably. What's new is if you pay attention to what you are multiplying each time, this is actually the base on your log. So if I look at this exact data, I'm going from 1 to 4 and 4 to 16 and 16 to 64 and 64 to 256. What are you multiplying by each time? 4. So 4 is the base on your log. So if I had y or f of x equals whatever my a is, log base 4 of x, okay? It could be a, you could have a variable after this, you could have whatever that model is, we don't know exactly what it is, but we do know that if you're multiplying by 4 each time, that the base on the log is 4. So if this is multiple choice, it might say which of the following can represent this data, and one of them might be exponential, and one of them might be log with a different base, one of them might have that log base 4, and you would know it's that specific one. All right, example 1 says, as the school day goes on, Mrs. Chris Weiser's classroom gets warmer, which is actually true. As the number of students increase, so does the temperature. And then we've got some data. So the number of students is your input and the temperature is your output. What do we notice about the pattern of your input and output? What's multiplicative, what's constant? I mean, what's linear or not linear, constant?
The number of students is multiplied.
Okay. Good. So the input is changing multiplicatively, output is changing additively, which means this is a log regression, okay? So we're going to use the calculator to actually find the regression equation. Let's put the data in. So go to your data chart, go to edit, go to stat, and put it in. 6, 36, 72, 144, and then 64, 66, and 68. If we had done this without a calculator, what would have been your base? What are you multiplying by each time?
6.
Yeah. Well, not each time. It's a little different, but we'll get to that. So put in your model, and then you will see when you go to run the regression, like when we go to stat and we go to calc, if you look in that list, so it's important that you're practicing this because we haven't done the log yet. Okay, when you look at that list, if you go through all your options, there is nothing that says LOG. Like you could scroll all the way through. And there is nothing that says LOG. There's logistic, which is not logarithmic. That's not the same thing. But what is in here that is log? The natural log. That ln is a log, right? So when you run a log regression, you are running an ln regression. I'm going to enter on it, and I'm going to store it because I'm going to answer questions. So alpha trace, put it in the Y1, calculate. And it's in the format of A plus B ln. ln x. So y equals, or f of x equals, whatever this is. So in this specific model, y equals 58.314 plus 1.829 ln of x. Everybody's to here? All right, so then B says, what's the temperature if there are 45 students? So is the students the input or the output? The students the input, right? So I'm going to go y1 of 45, or take that 45 and plug it in. So get out of here, alpha trace, y1, 45. Or you could have gone to your graph if it was in view and done value. So the degrees is 65.2765 to 2.77 degrees. Can degrees be a decimal? Yes. So I can keep that decimal, okay? If it said round to the nearest degree, obviously, then I would round it. But if not, I would keep the 3 decimal places. Still good? Yeah? Okay, then we go to C. How many students are there when the temperature reaches, and I changed that to 69 because 73 kept freezing our calculators. We had to go out so very far. So we're going to go 69. So now the degrees is what? Input or output? Output. How do I find out where my output is 69? Good. So my y1 is going to be this, and my y2 is going to be 69, and then I'm going to see where they intersect. So I'm going to go to the y, and I'm going to graph. And initially, it's not going to show up because my first input value is 62 degrees, right? So my x, the smallest one, is 64. My input is 6, sorry, but my y is 62. So it makes sense that it's not on this screen. So you can either zoom out or you can adjust your window. If I just adjust the window to go to like 72, so that I want to catch the top part of it, then the line appears, but not the intersection yet. So this ln is kind of so flat that you're not increasing by a lot each time. So I'm just going to hit zoom, and sometimes you're going to have to zoom out multiple times. So don't freak out. There's once. And I can try to see if it crosses. So if I do second, calc, intersect, and I have to get the spider with 4 legs onto the graph, it'll hit once, twice. And if I hit guess, if it's not in the view like that, I'm going to get this error, which means I need to zoom out again. So I'm going to go back to my graph, and I'm going to zoom, and I'm going to zoom out. And I'm going to try it again. Second, trace, intersect is 5. I'm on the curve, guess. And this time it worked. Oh, no, not yet. Go to graph. Zoom out again. And obviously we don't see it, but if your sign changes, your graphing calculator will catch it. So even though it looks like there's no way we could possibly determine it from looking at it, as long as your calculator can catch it, it will. So it says x equals 344.645. And what did the input represent? What was our unit on the input? Students. Can you have a 0.645 student? No. So how many students are in that room? Think about what you're rounding to. 345, I'd round up. Yes? Are there 345 people in that room yet? No. So this is where you got to really pay attention to what it's asking. You cannot round up on this because there's not 645 people or 345 people in that room. There are only 344. This is where the data modeling will get you. So be really careful, students. Like you have to think about them in terms of real world, right? You can't have like 0.645 of sometimes that much of your brain is here, but of your whole being, no. 0.00. Yeah. All right, example 2, the college admission rate for a university can be modeled by the function A, given by A of x equals 45.56 plus 12.72 ln of x. And A of x gives the number of admissions in thousands for x months after the first day of admission. So this time they gave you the model. I don't have to run a regression. It gives you the regression, okay? And your input is what? What does x represent? Months after the first day of admission, okay? And your output is the number of admissions or the number of people, right? Because it would be people in thousands. So A says how many students would be admitted after the 4th month? Is 4 our X or our Y? That's your X. So we're going to make our Y of 4. I'm going to plug that. Or you could literally just type it in, but letter B is I'm going to need to graph it anyway. So 45.56 plus 12.72 ln of X is my Y1. And I'm going to Y1 4. And I get 63.1936. So this is 63.194. But what is this in terms of? Students in thousands. So this time I keep a decimal because 0.194 is not a partial of a person. It's how many thousands it is. So this would be thousands of students, okay, if it asks for the unit. But you'd have to have the thousands there, or you'd have to move the decimal place. B says, during what month does the admission count reach 73,000 students? So I want to know that's now my output, right? Do I put 73,000 as my Y2? Why not? And what is my output in? In thousands. So 73,000 in thousands is what? 73. So my Y2 gets 73. So my Y1 is my model. Y1 is this guy. My Y2 is 73. And then I'm going to graph it. And again, 73 is not going to be on your graph. Because if it's your standard window, mine's already so zoomed out. I can't see it, but I'm going to let my calculator find it. So I'm going to go to my intersect. Make sure you're on both curves and guess. And it is 8.6471. So 8.647. What does the question say? What's the wording on it? During what month does the admission count reach? Does it tell you it starts at January? No. If it told you after a certain day, then I would give the physical name of the month. So if it said after January, then 8.6 months after January would be my answer, okay? But it doesn't, right? So we're going to say it's in blank month without a name. But if I take this number, 8.647, which month would I call that? Huh? No, what'd you say? But without a name. If it's the 8th month, right? Think about it. What happens? Let me say how to say this. If I say the result is in month 1, right? And I ask you how much is it after the 1st month? Is that the beginning of the month or the end of the month? At the end of the month. So if it's the 8th month, then we're talking about 8 would stop at the 8. 0.647 is into what month? Huh? The next month, which is the 9th month. So at 8, it hasn't reached 70. Like if you actually plug it in, if I plug in 8, right, I have not hit 73,000, if you think about it in terms of that. If I actually do Y1 of 8, I'm at 72.01 thousand. I haven't yet hit the 73,000. Example 3 says the number of bacteria growing in a petri dish doubles every day. There were initially 800 bacteria. So if you're thinking about something doubling, right, what kind of model is that?
Times 2. That's like
Doubling could be times 2, yes. If we think about it, so I guess there's 2 different ways to think about it. One would be that way. Doubling that way could be that log would be a base of 2. Yeah, but it's also what? Your exponential formula for doubling rate, yes? So that parent function is the initial times 2 to the x over t, where t is how long it takes to double. Hopefully we remember something like that, okay? That is your doubling formula. So what is the initial value? 800 times 2. And x over t says the number of times it takes to double. But if we keep reading, it says write a function of f that gives time in days. So we want to keep it in terms of days. If it doubles every day, then this would be x over 1. So I can literally leave it as that exponential model, okay? And this would be where my input is the number of days. and the output would be the bacteria growth, right? So then now read A. Write a function that gives write a function f that gives time in days as the output value. So now it wants the time as your output value, and it wants the B to be the bacteria as the input value. So how do I switch these? Think about how I could get to that exponent. I'm going to log it, right? So I can either switch my variables and solve for the other one, or simply just solve for the other one. So we are finding the inverse, but we don't actually find the physical switch of the variables, because really we're just solving for x. So if I had y equals 800 times 2 to the x, I now want to put this in terms of that x. So I'm going to divide both sides by 800. I get y over 800 equals 2 to the x. And then how do I get to that exponent? I got to log. Specifically, I want to get rid of this base, so I'm going to log base 2. So I get log base 2 of y over 800 equals the log base 2 and the 2 cancel, and I just get x. And x was my time, so this is t, and y was my bacteria, which they told me the variable is b. So in a function notation, this would be f of t equals log base 2 of b over 800. So when you have an exponential function and you want to switch the output and the input, it becomes log. It would be the reverse. If it was log, it would become exponential. Now B says, how many days does it take for the population to reach 20,000? Give me one way to find this. I could graph which one? I could graph what we just found. I could graph what we just found, and then the population is which variable? T is time. So the population is B. So I could actually just plug it in. I could get log base 2 of 20,000 over 800. So log base is in your math menu. Log base 2 of 20,000 divided by 800. And I get 4.644. What else could you have done? What if I worked with my original one? If I had used that, because it's still the same function, just solve for a different variable, right? If I had used that, then the population is what? The input or the output? Of my original one, my output is the bacteria, right? So I could have taken that, and you could do it both ways. I could take the y1 and make it your doubled, and you can make your y2 your 20,000, and you could see where it crosses. You would get the same answer, okay? And you could do both and check. But this is in term of days, right? How many days? Can a day be a decimal? Does that need to be rounded? It does not need to be rounded. We get to keep it. Okay. It didn't say on what day. That would be different. Okay, last one. Example 4. A weed grows continuously in a garden. The weed is initially 6 inches tall. The exponential model is H equals 6 times e to the t over 4. Write a function g that gives time in weeks as the output value and a certain number h for the height of the weed as the input value. So on my initial model, what's input? T is your input. That means times the input, and the output is your height, yes? Input is time. Output is height. A is asking for the reverse. So solve for the other variable or find the inverse, basically is what we're doing. So if h equals 6e to the t over 4, and I want to get the t out of the exponent, first thing I'm going to do is divide by 6. So h over 6 equals e to the t over 4. And how do I get to that exponent? ln, because the ln will cancel with the e. And I get ln of h over 6 equals, ln of e cancels, t over 4 and then I'd multiply by 4. So T equals 4 ln h over 6 would be my model if my input is the height, which is what it wants. The height is the input, and the time is the output. This time it says G. So G of T equals 4 ln h over 6 would be the right way to write that. And then B says, find the number of weeks it takes for the weed to reach a height of 20 inches. So what's one way to do it? Because there's more than one. Just plug it into the new model, right? Height is my input on the new model. So 4 ln of 20 over 6. 4 ln 20 divided by 6. And I get 4.8158, so 1/6. Or what else could you have done with the original model? If I use this original model and I want to find where height is 20, is the 20 the x or is the 20 the y2? It's the output, so it'd be the y2, and I'd see where they cross. And again, you could do both and check. And this is weeks. Can weeks get a decimal? Yes, it didn't say during what week. If it said during what week, which would have been your answer? The 5th week. Because 4 is under, it hasn't hit 20 inches yet, right? F of 4 is not quite 20 inches yet. So the only time you round down is if you're counting something that cannot be a decimal, and you're not asking for output. You round down if it gives you the input. Does that make sense? Yeah? And it's a whole person, a whole thing. You can't have a partial person. You can't have a partial animal. You can't have, like, those kinds of things. We keep whole numbers. All right. We're done with the notes, but we're going to do one more thing together. Okay? Oh, just whine all you want. Okay, I want you to remember this moment right now, and then in 7 minutes, you're going to be like, I'm sorry I did that. Because over the break, you're going to have an extra credit opportunity, you little jerks. Okay? So this is, first of all, I want you to do this with me, because it will be easier. You're going to go, it's not on your to-do list yet. So you're going to go to Canvas, you're going to go to your calendar, or you're going to go to modules. If you want to sleep through this, that's fine. That's your extra credit opportunity. I don't care. It's less I have to grade. I'm so down. And also, maybe you get into heaven because of this stuff. Some of you could use it. Modules, right? If you, it's on the general information. I did. In the year before? Yeah. Well, but I had to tweak it. General information module is where it is, or it's on your calendar. Do the day we get back. Okay, so here's the instructions, and then I'll give you the play-by-play after. Okay, so I'll tell you, I used to do this, like, I think, like, out of the kindness of people's hearts, maybe they will do this, and then you realize you're dealing with teenagers and you have to be bribed. So then it got attached to, there is a reward. Okay, you are from this list of 8 options going to complete 3. You can complete more if you would like to, especially if you've been naughty and you want to get on Santa's good list. Okay. So 1 is tell your parents how much you love and appreciate them, and especially do this if you don't do that often. It will be an interesting little experience. 2, call a grandparent, relative, or friend that you haven't talked to. Physically talk to them on the phone or in person. Like if you're going to see them Thanksgiving, this could work too. 3, make a list of goals for yourself, at least 3 short-term and 3 long-term goals. 4, do something nice for a stranger, and I do not mean hold the door open. You should already be doing that, okay? But go out of your way to do something nice. 5, send an email to your favorite teacher, past or present, telling them how much you appreciate them. You do not get extra points if it's me. Make somebody else's day, okay? 6, do volunteer work. 7, say a sincere prayer of thanks to God for all of your blessings, which for some people is very difficult. So think if that's easy for you, that's great because you do that a lot. And 8, write a letter of gratitude to somebody that's impacted your life and read that letter to the person. So this is kind of based on that like gratitude experiment if you watch the video at the beginning. And I will tell you, I've done a lot of these, but I did that one year. Like I told the kids, write a letter, blah, blah, blah. And I was like, maybe I should try this. And I wrote a letter to my mom, who my mom and I have a great relationship, and I tell her I love her all the time. And I literally put it in my kitchen, and I was like, whatever. It was a thing I did. And then I said, no, I tell these kids to read it. I'm going to read it. I called my mother, and I read that. And what an amazing experience it was for both of us. So I would highly recommend that you do something like that, okay? And then read it to them, because it's not just about, I mean, it's awkward at the beginning. They're like, what are you doing? And you're like, just listen, right? If you do 3 of these things, then you have to share the experience with me. So I used to do it as a free gift, and then I got yelled at because it didn't involve math. So we're going to involve math. We are going to involve math. So if you have it open, we are going to involve the math on this. It's on the calendar or on the module because it's not on your to-do list yet because it's too far out. Well, so here, this is like the feel-good part. This is your gift back to me. Is you're going to share your experience with me. And it says 2 to 3 sentences. It could be, I chose to do blank, and it was an amazing experience because. That would be awesome. If it's your goals and they're personal, you do not have to share your goals with me. Hang on. If it's a convert, like you don't have to get personal and share information if you don't want to, okay? I have gotten pictures before of like somebody bought a homeless guy a pizza and then like brought him the pizza and like took a picture of it. That was super cool. Like one of my favorite things. But it doesn't have to be that level, okay? But it is not like I'm going to hold the door open. Stay there because I have to take a picture. Don't make it awkward, okay? But you're sharing about your experience. And then on the second page, we're going to math it, okay? So, yes. Make it a verb. The idea behind this is a pay it forward scenario, right? So if you are a person and you go out and you do 3 things, we're going to say you affect 3 people, yes? At minimum, 3 people, okay? And then if they were then to go out and do this challenge, those 3 people would each affect 3 people, making it now how many people? 9 people. So if you're going to do a diagram to show your 5 rounds, okay, then you start with you. You're the start. And then you would go to 3 people. And then each of those 3 people go to 3 people. And then you keep going. So this would be round 1. Round 1 is you. Round 2 is the 3 people. Round 3 would be the 9 people. And then you're going to go 2 more times. If you're artistic and you want to make this cute, this is also super fun. Like people have made these little emojis like little turkeys or little whatever. Little stick figures. This is a very cute thing if you like to draw. Okay. Pause because we're going to move on. That's fine. All right. That's fine. It's cute for me, but the point of this is for you to go out and do something good. So at the end of the day, that's what you're doing. Okay, so fill out the chart using X as the round and Y as the number of people affected. So if we say you start, you are 1, right? You are the first X. How many people are you affecting? 3. If we go to the next level, at 2, how many people are they affecting?
6.
Nope. Each of those 2 people. Sorry, the input is 2. It's not 2 people. The input is 2. So second round goes to 9, right? Then the third level, how many are now getting affected? 27. Fourth, 81. Fifth. Good. 243. What kind of model is this? Exponential. What would the base be? 3. What does an exponential model look like? It's a curve. It would be at 1, it would be 3. At 2, it would be 9. And then it gets so big it goes like off the graph. And then use the equation to find the amount of people would be affected after 10 rounds. So 10 goes where? To the exponent. And then you're going to take out your calculator. And you're going to find 3 to the 10th.
Is 59,049.
Imagine if it actually happened. You make almost 60,000 people's days. So this will count as a homework out of 0 points. So if you get 100, you get 100 out of 0 points. If you already have 100 on your homework average can go above 100 and help out your other averages. If you missed a homework or there was one you got 90 on, whatever it is, it will make up for those points. Okay?